Good morning friends, I welcome you all for my YouTube channel. Okay, so in previous session we were discussing some problems, worked example, some of the important problems, right? Let's continue the same. We'll discuss couple of problems and then we can move for the next exercise, which is totally based on the properties of the determinants. Okay, so let's see what is the next one. So here they have given if x, y and z are different. So x, y and z are different, then they have given a 3 cross 3 determinant which is equal to 0, then we are asked to prove that 1 plus xyz is equal to 0. We are asked to prove that 1 plus xyz is equal to 0. Okay, so what is the meaning of x, y, z are different? That means x is not equal to y, x is not equal to z. Similarly, y is not equal to z. So x is not equal to y and not equal to z. All three are totally different. Okay, fine. Let's proceed with this. Delta is what? X square 1 plus x cube, y square 1 plus y cube, z square 1 plus z cube. Okay, so this is our given determinant, right? So here you can see third column is sum of two terms. This third column is sum of two terms. There is 1 and x cube, 1 and y cube, 1 and z cube. So property 5 says that if every element of any row or any column is expressed as sum of two or more elements, then whole determinant can be expressed as sum of two or more determinants, right? So then we can express this whole determinant as sum of two determinants. Why? Because this each and every element of third column is sum of two elements, two numbers, so that we can express the entire determinant as sum of two determinants. So let's see how to express that. I can write this as x square 1, y square 1, z square 1 plus x square x cube, y square y cube, z square z cube. So which is having third column is is the sum of two terms. So third column third column becomes this first entry 1 1 1 and here second x cube, y cube and z cube. Remaining column remains same. They are not going to change. Okay, so this is there. Now I can directly solve this one by expanding to any row or column. There is no restriction, but the problem is it is as usual, as I said, it will become a lengthier, right? So to avoid that, I will apply some row transformation. Okay, I will apply some row transformations and then I will row or column transformation and then I will make it simple, right? Now C2 interchanges with C3, okay, and C1 interchanges with C2 only for first part. Okay, only for first part. What I am going to do is C2 I am going to interchange with C1. Once this C2 and C2 I am going to interchange with C3. Once this C2 and C3 are interchanged, then I am going to interchange C1 and C2. Okay, I am going to interchange C1 and C2 only for first part. That is only for first part. So what happens to delta? That is determinant. See, C2 interchanges with C1. Sorry, C2 interchanges with C3. So let's make it stepwise to avoid confusion. Let's take only one step. First, C2 interchanges with C3. C1 is unaffected. Right? C2 is interchanging with C3. So C2 shifts to C3 and C3 shifts to C2. So C2 becomes C3. What is C3 here? 1, 1, 1. That will come here. 1, 1, 1. And what is third? C2 is coming to third column. Right? So here we will get x square, y square, z square plus, here I will take x common, x from first row, y from second row, z from third row, right? X into y into z, right? If x comes 1, here x square becomes x cube becomes x square, y becomes 1, y square becomes y cube becomes y square, z becomes 1, z square becomes z cube becomes z square. Okay, fine. So now I have applied this property, C2 changes to C3. Now I should apply one more property. I should interchange C1 and C2. Should interchange C1 and C2. Okay. C1 interchanges with C2. So then delta will be equal to, see, C1 becomes C2. So C2 shifts to C1. 1, 1, 1, x, y, z. So this remains as it is, x square, y square, z square plus x, y, z as it is, 1 x square, 1 y square, 1 z square. Okay, so this is how it will change. Okay, so now I have interchanged. You can see both the determinants are same. If you see, observe that both the determinants are same. So when both the determinants are same, I can take this determinant common. So this is x. I can take the determinant common. So delta, I can write it as 1 x square, 1 y square, 1 z square. So if determinant comes out, what remains here? This is 1 plus x y z, right? 1 plus x y z. If I open the bracket, this into 1 will become this determinant, plus this into x y z will be x y z into this determinant. Once again I will get back the same value. Okay, so now you can see I have 1, 1, 1. So I can reduce this determinant. I can make R2 changes to R2 minus R1. R3 changes to R3 minus R1. Okay, R1 changes to R1, R2 changes to R2 minus R1, and R3 changes to R3 minus R1. So what will be the value of delta? 1 x square, 1 minus 1 0, z minus y, z square minus y square. Here 1 minus 1 0, z minus x, z square minus x square into 1 plus x y z. So this will be 1 x square, 0, z minus y. So z square minus y square I can write z minus y into z plus y, z minus x. So this is z minus x into z plus x. Okay, so now I can take z minus y, I can take z minus x outside into 1 plus x y z. So this can be written as 1 plus xyz. This one I am writing here. If I take z minus y from the second column and z minus x from the third column, so z minus x into z minus y, what will be left here? 1 x square 0 1 z plus y 0 1 z plus x. This is how it will remain. Okay, so now I need to expand this determinant to get the value. I can expand it through first column. If I expand it through first column, so what will be my value? 1 plus xyz into z minus x into z minus y into 1 into this determinant, right? So directly if I solve, 1 into z plus x minus 1 into z plus y. So this will be 1 plus xyz into z minus x into z minus y, right? So plus z minus z cancels into x minus y. Okay, so this is the value of this determinant. But what about the value of the determinant? They have given as equal to 0. So this will be equal to 0. So this particular equation will be equal to 0. So now what you need to observe here is they have given that x, y, z are different. That means x is not equal to y and x is not equal to z and y is also not equal to z. So here what you need to do is, if x is not equal to z, then z minus x will not be equal to 0. If z and x are not equal, then z minus x will not be equal to 0. Z minus x will be equal to 0 only when z is equal to x, right? So z minus x is not equal to 0. Similarly, z minus y and x minus y also will not be equal to 0. When z minus x is not equal to 0, z minus y is not equal to 0, x minus y is not equal to 0, then what will be equal to 0? 1 plus x y z will be equal to 0. 1 plus x y z will be equal to 0 as x is not equal to y is not equal to z. So x is not equal to y and it is not equal to z. So 1 plus x y z is equal to 0. I hope the concept is clear for you people. So what you do is go through my video very slowly. You will understand it very carefully. Alright. So now pause the video for the moment and make the note of this. Okay. So students, I hope you have understood that previous problem. Okay. So let's start with the one more problem. Let's solve one more problem and try to understand the concept. By solving more and more number of problems, we will be perfect with the tricks, perfect with the transformation, perfect with the properties, all the things. So let us solve one more problem before we are going to start with the actual exercise. Okay. So here what they have given the 3 cross 3 determinant. This is, they have given it as equal to, we need to prove it as equal to ABC into 1 plus 1 upon A plus 1 upon B plus 1 upon C, and also as equal to ABC plus BC plus CA plus AB. So how to proceed this? So let's see what we can do here. Okay. So given determinant is what? 1 plus A 1 1 1 plus B 1 1 and 1 plus C. This is the given determinant. Okay. So now what I will do here, I will multiply A and divide A for first row. I will multiply B and divide B to the second row, and I will multiply C and divide C to the third row, right? To all the elements of the first row, second row and third row. For the first row, what I am doing, I am multiplying by A and dividing by A. For second row I am multiplying it by b, and also I am dividing it by b. And for the third row I am multiplying by c and dividing by c. So what happens? A into 1 plus a divided by a, and here 1 by a into a, and this is 1 by b into, 1 by a into a. So I have divided the entire row by a and multiplied the entire row by a. Similarly for b, for second row I am dividing and multiplying by b. So 1 by b into b, here b into 1 plus b divided by b, and here 1 by b into b. I have multiplied and divided by b. And third one, same thing, 1 by c into c, 1 by c into c, and here c into 1 plus c divided by c. This is about third row. Okay, now we got it. So now what I will do, I am having a and a, I will take it outside. So a from the first row, b from the second row, and c from the third row. A and a I have taken outside from the first row. B and b I have taken outside from the second row. C and c I have taken outside from the third row. Okay, then what is left? 1 plus a by a. 1 plus a by a can be written as 1 by a plus 1. Right, if you take LCM, you will get 1 plus a by a, or you will divide it separately. 1 by a plus a by a. What is a by a? 1. So it will be 1 by a plus 1. Here, if a is outside, 1 by a will be there. Here also 1 by a. Now b is outside, 1 by b. Here, as usual, b is going, 1 plus b by b remains. So that can be written as 1 by b plus 1, and b goes, 1 by b remains. And here same thing, 1 by c. Okay, 1 by c, and here c comes out, 1 plus c by c, which can be written as 1 by c plus 1. This is how it will be there, right? So this is the determinant. Now the determinant. So now, so I hope this is clear. So next, what we need to do here is R1 changes to R1 plus R2 plus R3. So R1 is going to change as R1 plus R2 plus R3. So then what will be the value of determinant here? See, R1 changes to R1 plus R2 plus R3. So what it will be there? 1 upon A is there, 1 upon B is there, 1 upon C is there, and 1. So it will be 1 plus 1 upon A plus 1 upon B plus 1 upon C. Okay. And here 1 upon A is there, 1 upon B is there, 1 upon C is there, and 1 is there. So this also can be written as 1 plus 1 upon A plus 1 upon B plus 1 upon C. Okay. And here also I am having 1 upon A, 1 upon B, 1 upon C, and 1. So which can be written as 1 plus 1 upon A plus 1 upon B plus 1 upon C. And we have A, B, C outside, so keep it outside. Okay. So row 2 and row 3 will remain same. 1 upon B, 1 upon B plus 1, 1 upon B, 1 upon C, this is 1 upon C, and 1 upon C plus 1. It will remain as it is. Okay. So now see here also 1 plus 1 upon a plus 1 upon b plus 1 upon c, 1 upon a plus 1 upon b 1 upon c. All these are same. I can take them out. Delta is equal to ABC into 1 plus 1 upon a plus 1 upon b plus 1 upon c, 1 1 1 1 upon b, 1 upon b plus 1, 1 upon b, 1 upon c, 1 upon c, 1 upon c plus 1. Right? So now we have simplified this to a greater extent. Still a little bit simplification is possible. Right? So here when 1 and 1 is there, both the values can be made as 0. How? C2 changes to C2 minus C1 and C3 changes to C3 minus C1. So then what will be my determinant? A, B, C into 1 plus 1 upon A plus 1 upon B plus 1 upon C into 1 upon B, 1 upon C as it is. Right? 1 minus 1 is 0. So 1 upon B plus 1 minus 1 upon B. So it will be 1. 1 upon B, 1 upon B cancels. 1 remains. Right? And 1 upon C minus 1 upon C, 0. So 1 minus 1, 0. 1 upon B minus 1 upon B, 0. 1 upon C plus 1 minus 1 upon C. Plus 1 upon C minus 1 upon C will cancel. So what remains? Plus 1. Now it is totally simplified. Okay. So that we can easily calculate the value. You can expand it to first row. So what will remain? A, B, C into 1 plus 1 upon A plus 1 upon B plus 1 upon C into, see, first one is 1 into this determinant 1 0 0 1, because we need to leave first row and first column. What remains? 1 0 0 1 inside the determinant. So 1 0 0 1 can be calculated 1 into 1 minus 0 into 0. Right? Right? So what we get here? This is equal to ABC 1 plus 1 upon A plus 1 upon B plus 1 upon C. Right? So because 1 into 1 is 1, 1 minus 0 is 1. So this entire thing becomes 1. So only this part remains. So we have proved this part here. Now this is to be proved. How? You take ABC inside. You take ABC inside. So if I take ABC inside, so what will I get? ABC into 1 is ABC into 1 is ABC. When ABC is multiplied with 1 upon A, what happens? A and A will cancel. So what remains? B into C. When ABC is multiplied inside for 1 upon B, B and B cancels. What remains? AC. Right? Similarly, when ABC is multiplied inside, C and C cancels. What remains? AB. Okay. So this is how you should prove that. Okay. So you can see here we got ABC plus BC plus CA. AC is nothing but CA plus AB. Alright. And we have got this value also. This is how you need to do it. So what you do is pause the video here and make a note of this. Okay friends, I hope you have understood this problem here. Okay, so we have solved two problems. The two I went very carefully. All these the 4 problems, 4 to 5 problems, whatever we have solved. The two previous session last problem, that is we need to prove which was needed to prove it as equal to 4ABC. This is a very important example. It has appeared again and again in your examinations. So kindly take care of that. Go through that video very clearly, and if any doubt is there, as I said, you let me know in the comment box. I will get back to you. Okay. So in spite of this, you can solve many problems as usual. So you will be perfect in that. So with this sessions, with this problem, we are going to end up the session here, right? So in upcoming session, we are going to start with the exercise, that is second exercise of your determinant. All right. So it requires 2 or 3 sessions. We'll finish it, then we can move on to the next topics. Okay. So we'll take a leave here, right? So in the meanwhile, you keep trying the problems. Okay. Take care. Goodbye.